Okay, fraction routines using Cuisenaire rods. This is addition of fractions part 3. We're getting more and more complex. I want to remind you that you don't jump from part 1 to part 2 to part 3 this quickly with students. I'm doing it with you as teachers, but with students, they're going to need multiple repetitions of each part. Okay, so this is becoming more complex now. Notice that I'm creating a hole that is a combination of two rods. And I'm still scaffolding heavily here. So I want to know, okay, what's the value? If this is one hole, what's the value of one of the greens or the large greens or the dark green, I should say. So encourage students to do this, to actually create the hole and then compare, let's see. I want to get some more blocks here. Compare, let me just dump these out. If I haven't already mentioned it enough times, I like to make double bags, so there's a double bag. Okay, so compare this dark green one to the whole, and I'll notice, okay, so because it takes two dark greens to be equivalent to the whole, then I'll say that this is 1/2. Once again, you should always require students to give the reasoning. That's what my ellipse stands for there. I'll do the same thing, comparing the light green to the whole. Let's see what I get. Looks like I'm going to need another one. So yes, so it takes 4 of the light greens to make the whole. So this is 1/4. Again, give the reasoning. And now keep in mind, I can't add 1/4 and 1/2 because in your terminology that you use in class often, they need the same denominator. But in my terminology here, what I mean is I need the same color blocks. So I'm going to change this one into, now this becomes 1/2 plus 1/4. And we've already done this problem, you know, using different color blocks. The reason that this is a more complex problem is because it has a whole that requires a combination of blocks. So this is 2/4 now plus 1/4. And what does that give me? Yes, that's correct, 3/4. And I want you to, of course, require the students to give the reasoning. Okay, so I've done the 1/2 plus 1/4 more than once. Of course, you should require students to do the problems more than once using different manipulatives and different setups. But now I'm going to take us to another step, like a step, I guess I would say a step higher, so to speak. So let's see. Let's go with this. Let's do this one. Let's make a hole that looks like this. There's a 5 and a 6 and a 10 unit. So now I'm going to create a hole like this. This is equal to 1 hole. Okay, this is, now, if you remember referring to this over here, my reference model, that's 10 units, that's 5 units, and that's 6 units. So 10, 6, and 5, that's actually 21 units. So I'm going to choose now a 7 unit. And what will that 7 unit be? It's the black. So I'm going to say, what's this value right here? And I'm also going to take a 3 unit. A 3 unit is one of these right here, but I'm going to actually make it a multiple of a 3 unit so that it looks something like this. So I want to know, what is this? And then I want to know, now this is addition of fractions. What's the value of this? So look what I've done. I've taken a 21 unit whole. I've said, what's the 7 unit? What's these 3 units equal to? And then what's the sum of those two? So, okay. So first of all, compare the blacks to the whole, and you should get that this is 1/3. Tell me the reasoning. Then now what they have to do is figure out what's the value of one of these green ones. So on their own, they should be able to say, oh, this green one is equal to 1/7, give the reasoning. And then based on that, then this is equal to 3/7 and give the reasoning. So what we have here is 3/7 plus 1/3. By the way, you should also have some activities like, which is greater, 1/3 or 3/7? Well, look at it. 1/3 is smaller than 3/7. Okay. Now, okay, so, but we can't add those up. In your terminology that is common in classes, you'd say, well, they need a common denominator, and you have a procedure for getting that. But in my way of thinking, what I need to know is how can I get the same size blocks? And so I'm going to look at one of these right here and notice, oh, there's 3. Then I have to also compare these white blocks over here. And to do that, I'm going to line up all the blocks, but that's 10. Remember, that's 6 and that's 5. So I know that that's 21. So this is actually equal to 1/21. All right. I could do this right here and block and figure out how many go here. That would actually be 7/21. And then there's 3 of these, so this is 9/21. Now I'm doing this very quickly to make a shorter video, but this is a fairly complex problem. And so now what do I have? 9/21 plus 7/21, and that should give me 16/21. All right, and that is the answer. You may ask yourself, oh, could I make it in even smaller, or could I reduce? What I mean is, could I reduce that fraction? And the answer is no, you can't. But I would encourage you to convince yourself of that. One way to do it is, this is 2 raised to the 4th power. So the only factors of this number are 2. And there are no factors of 2 in that number because it's not even. So that is a completely reduced fraction. All right. This is an advanced form of that. What we want to do is to provide multiple opportunities for students to do less advanced problems, and then transition them into more advanced problems. And that's going to take time. And so that's one of the reasons why I would like, and by the way, I want to continually emphasize every time in these videos, when you see me writing an ellipse like this, it means that the reasoning goes there. You need to provide time and a requirement in every activity for a student to give the reasoning. They need to give it in words, either verbally, like telling the group, and or in writing, so that they write it down. That is language development. Specifically, it's cognitive academic language proficiency. It's building that proficiency. So what we call CALP, or like I said, cognitive academic language proficiency, which is the biggest challenge for most of our language learners. And for you to be able to develop that CALP requires many opportunities for students to speak using academic language, and for structures that help them to scaffold that academic language. All right. I'm going to do a couple of more examples, but I just want to end this video here.